So in 2022, we officially registered this company, the three of us, Shriman, Balázs and myself. It's actually two Hungarians and an Indian making a Dutch company, so it's very multicultural. What we do is machine perception with a heavy focus on radars. And the short slogan is AI for radars. We make these sensors smarter with next generation perception.
Basically, you study computer science, you do some projects on drones, on autonomous vehicles, you do your PhD, and at some point you decide to create your own company and focus on radars. Why did you decide to create your own company, and what is your company doing?
Every conference I go, radar is getting more and more popular. It's like from at the high school reunion when the used to be fat kid shows up and then it's now super fit and handsome. That's how it feels like radar.
So the 10 million question is, when do we get fully automated vehicles? Elon Musk says it's next year, every year. So is it next year? This episode is brought to you by Training Data. If you're new in data science and want to get into the field, or if you're already in the field but want to progress, well, Training Data is the platform for you. They offer courses on feature engineering and selection, model tuning, interpretability, and much more. You will get both the math and the intuition behind each method, but also Python code ready to power your own projects. So if you're interested, visit the link in the description and don't forget to use the code AI Stories to get a 10% discount. All right, so hello everyone and welcome to the AI Stories podcast. I'm Leiser, I'm a senior data scientist and I will be your host. So today our guest is Andras Palffy. Andras is the co-founder of Perciv AI, a company which offers AI-based software solutions to enable robust and affordable autonomous systems. Prior to this, Andras had a bunch of experiences. He did his PhD at Delft on road user detection, and he also worked as a postdoc there on machine perception with automotive radar sensors. So this conversation is going to be full computer vision, full AI applied to autonomous driving. If you enjoyed the conversation, please subscribe to the AI Stories YouTube channel, comment, share, or leave a 5-star review. All right, so let's start now. Hi, Andras. Hope everything is going well for you. The first thing I wanted to ask is, tell me a bit more about your background and how you actually got into this world of data and AI. How did you get into the field?
Yeah, hi there, and hello everyone. Thanks for the flattering invite. Very glad to be here. And that's a great question. I was thinking about it a while before because you sent some questions ahead. I think I have a great answer. I would say it was my mother who realized that I had some definitely technical motivation or skills, but then she pulled a trick on me. She said that she has a great movie for me to watch, which was the Titanic, and she said that it has robots on it, underwater robots. And you know the opening scene when they go down with the robotic submarines and whatnot. And yeah, it turns out that's like 5 minutes of the movie, and then it was a romantic movie. But I really enjoyed that part. I guess that's left a big impression. So I was really into robots, even in high school. You know, these Lego kits that you can play with. So I got one of those for a Christmas, and then, you know, built all this crazy stuff, that line following and self-balancing and these kind of robots. And it was clear for me around like 15 or 16 that I want to make computers understand what's going on around them. And that took me to my first university in Hungary, doing exactly this.
And so how did you get into autonomous vehicles then? Why did you get interested in this particular topic because you did your PhD in kind of autonomous driving, road user detection, but it looks like all your previous experiences are related somehow to autonomous driving. So how did you get interested in this?
Yeah, so this is back in 2016, right? It's 8 years ago. Self-driving was extremely hot. Everyone was saying that, oh, next year it's all solved. It's still not solved. They still say that. But so there was a big hype. Also, the company I worked for, we were doing ADAS, aftermarket ADAS, they called it. So not built in your vehicle when it comes, but something that you can put on your dashboard, and then some beeping when you're not paying attention. These kind of things, which are still very much offered now, a bit more fluent, of course, in cars. So that exposed me to this kind of world. Also, the hype was there, and then I was like, yeah, what's the coolest robot I could work with? And turns out, like, a car is a robot, right? It moves on its own, and I looked into this topic.
Okay, so can we dive a bit maybe into your PhD? Was this your first experience with autonomous vehicles? What was it? And then can you talk also about your PhD and the work you did there?
Sure thing. Feel free to interrupt anytime too.
Yeah.
I don't want to get into a monologue, but yeah, as mentioned before, there was a so I did a bachelor and a master degree in Hungary. This was the Peter Pazmány Catholic University Information and Bionics Technological Faculty. I think that's the English translation. And there I was already really moving towards robotics and sensing computers, it was called. And what really gave the final push into this direction is an internship position as a startup. It was called EU TechUs, which is
Hmm.
EU like Europe and US us, connected by tech. It's a small startup. So back then it was like 20 people. Then when we exited, it was 40 people. And that's what we did. Computer vision for different kind of things. Embedded. So it was very, very power efficient, running on a something like on a matchbox size FPGA based. This is before CNNs, before deep learning, the old school stuff, like filtering and projections and edge finding and these kind of things. And there, as mentioned before, there is a lot of ADAS applications that, hey, can we detect the car in front of us using one watt of power? So it's like really nothing and everything. I was an algorithm researcher, which means that I never really touched this hardware. I was working, in a nice uh, desktop
Hmm.
workstation, but I could only use like very much predefined tools. It's like using Lego blocks, and then, okay, how do I put these things together, which were very efficient, and the engineers down the line could use it on the actual product to detect that car. And then the whole topic clicked on me that, okay, this is both very exciting and both super not solved. Like whatever we did, there were always a new situation or something, which was very challenging. And then for different reasons, I wanted to. So this was after I did a master's in UK in Cranfield. That was with drones, by the way. It's still self-driving, something
Okay.
just flies. And there the task was. That's also interesting. If you would like to chat
Yeah,
about
yeah, yeah. Go ahead. I'm
it.
interested.
There, there we did an indoor mapping solution where the drone was flying up and down, but given that it has a limited battery life, remember this was 10 years ago, so it wasn't like, half an hour and you can buy it in the closest Walmart. Um, we also had a ground station, which was a moving robot, and then the flying robot should land on the moving robot to charge, and then it can take off again, and then it's good for, I don't know, search and rescue and this kind of missions. So then it's again was a computer vision task to find where the landing station is, and then that was my second master's in the UK. And after that, I went back
Sorry,
to this. Yeah,
question on
yeah,
that
please do.
already. So, well, it was 10 years ago. You mentioned it was pre-CNN. What kind of algorithms do you use, like for example, to detect this moving station, or even before at your internship or full-time job at
Yeah.
the previous company? What are the algorithms that you used, and what were the limitations there? Why is AI better than previous algorithms, basically?
Well, there's it's a gray zone how you define AI. So as long as it's artificial and kind of intelligent, you can call it AI. So I guess even that was AI in a weird way. It definitely wasn't deep learning, which is, this deep neural networks. So what we had is actually very old algorithms, support vector machines, for example, or random forest, like exploded decision trees. So classical artificial intelligent algorithms,
Okay.
which you can still train, but definitely not as deep as current methods. So, like a support vector machine is like a single neuron. So instead of millions of setups, it's a single one. And I guess the biggest difference would be how you get the features based on you make these decisions. And nowadays, this feature extractor part of especially images, but also for point clouds is left for the network to figure out
Mhm.
that, okay, do something with convolutions and just learn what features is important for you. Back then, it was basically handcrafted. It was the hawk features, it was the har features, the original, these old school digital cameras which detected your face quite early. Though those used these features, it's like, okay, things like this part of your head is usually darker than this part, or at least there's a contrast depending on skin color, and then this is different, but there is some edge here. And if you find enough of these well-defined but very simple features, and then you put a nice structure on it, then bam, okay, that's a face. Then we put it on cars, then bam, that's a car. This kind of thing.
Okay, so in the past, the big challenge was there was a lot of work on finding the right features to feed into your models, and the models you use were quite limited. As you mentioned, SVM is like a single neuron. Nowadays, with CNNs and deep learning, you don't really spend much time on features. You feed the images or you feed the data to the neural network, and the neural nets try to find the best features. Essentially, is that correct?
Yes, I think that's a good conclusion. um, it was good times and bad times, right? So very limited set, but you really had to think of it, what you can do with what you have available.
Mm-hmm.
Today you just smash the latest YOLO
Mm-hmm.
V10 or something, and then
Mm-hmm.
it kind of solves the problem. It will probably be better than whatever we did back then. It won't be more efficient though,
Mm-hmm.
right? So that was the big thing.
Okay, okay. And so after your master and after your work at EU Tech US, is that how you called it? This company
Yeah,
you.
it's the jury is still out, even though the company doesn't exist anymore or it's merged with Verizon. It's We called it EU Techas.
Okay,
Yeah,
EU Tech US. And after that, you did your PhD then.
yeah. So I had a deep motivation to really push the academic, achievements that's possible for me. And I got a big support for that from my family. They actually always push me that, yeah, master degrees is nice, but you
Mm-hmm.
could do more. And there were some options that maybe at the startup we can do some like industrial PhD or something like that. Unfortunately, with the mergers, so this was all acquired by Verizon, by the huge telecommunication company, and all these sweet solutions where, okay, you do half PhD, half work for the startup was off the table. So then I had to decide that, okay, do I stay? Do I do something else? Or do I pursue my old dream to finish a PhD? And I thought that this exit was a nice time to do the latter. So back then, to the previous topic, it was the self-driving hype back then. And so I was looking for self-driving PhD positions. There were a couple in Europe, not that many. There were also some in US and Singapore. And my parents are always going to be happy that I didn't choose the Singapore option in the end. It's we are Hungarians, by the way, if that wasn't clear. So anything in Europe is, yeah, kind of neighborhood. You can fly there in an hour or two, but Singapore is a different game. And yeah, I found this Professor Gavrila, um, who worked for Daimler, the Mercedes brand, for 20 years, doing pedestrian detection. So back then, when the Mercedes C-Class wasn't, hitting you, then it was him and his team. And he also decided that, okay, it's time to go back to academy, just of course on a very different level than I was. And he started this lab in Delft. And yeah, he was a very popular guy to work with. So he got like 200 applications for this PhD. But yeah, I was tricky enough to go to a conference where he was also attending, and I just jumped on him on some corner that, hey, I would be very interested. Can we talk? And yeah, I guess he liked the straightforwardness, and we kept on doing interviews, and he accepted me, which I'm very grateful. And that's how I got to Delft.
Okay. And so what kind of problems did you solve there? You mentioned it was pedestrian detection, but yeah, can you dive into maybe one detailed line of research that you took, something that you found, or um, and
Sure,
yeah.
sure. So even back, if you just Google self-driving car, many pages, many YouTube videos claim that, oh, this is solved, it works, and whatever. And our biggest problem or niche was that, yeah, but nowhere in Europe you don't see this, because it's a very different culture, it's a different architecture, different way we move around. Especially the Netherlands. I don't know if you ever been to, but we have more cycles than
Hmm.
people in the country. And that's in the literal sense. So just more or less staying in the road and not crashing into other cars just won't make it here. So that's what this professor and the whole lab focused on: how to detect the vulnerable road users, we call them, which is pedestrians, cyclists, maybe moped users, so whoever is in the worst position in a crash. So that was the focus. And then everything we did was driven by this. And then one biggest pull was, okay, how to detect these in a very reliable 3D way. And then everyone was doing CNNs and doing the, I don't know what was, YOLO 3 back then or something. It was still doing okay, uh, putting nice green boxes around pedestrians. And to be honest, it was really nice to publish in that kind of domain, right? Whatever you did, there was a Chinese university coming out with a better version the next week, and that's how it should be. So competition is good. So I think my topic was officially named sensor fusion based vulnerable road user detection. And sensor fusion means that you don't just use a single sensor, but you look into other sensors as well. And then these cars usually have three main sensors. One is the camera that you very well know. And then there is the lidar scanner, or laser scanner, it's also called, which is a really neat sensor. It maps your environment in 3D with literally a million points or more per second, or like 4 to 5 million with the latest generation. It's very, very expensive. It's very fragile, and it doesn't really work in bad weather. And then there is radar. And radar is like the bastard kid in old middle ages stories who was, left out of everything, because it's very robust, very reliable, and extremely hard to work with. It's a bit I wouldn't call it stupid, but like the output is so noisy and so simple in terms of amount of data that
Mhm.
academy just ignored it. Basically, let me put it this way. So we kind of started working on it. That hey, can you make something more out of it than people thought before? So it was more of a guessing. It was more of a okay, we need sensor fusion. What sensors are there, and let's try radar. Kind of trying out or luck. And yeah, it we got lucky in that sense, because it turned out that yeah, you can do much more with these radars than people thought before. And what I mean by that is usually even now, if you buy a car and you take it to the highway, it will not let you crash into the car in front of you, and that's ACC, that's a cruise control. And that doesn't tell you that that's a car. It tells you that there's something moving
Mhm.
pretty fast and it's very metallic, and press the brakes. What we did is like a much more advanced thing that, okay, based on the little radar reflections, I believe that that moving stuff is a pedestrian and that's a cyclist and that's a car, but there I can drive because it seems free. And while this is kind of trivial with the other two sensors in good weather, it's really tricky with radars.
Okay, makes sense. So radars is what you do with radars essentially is you collect a bunch of data and then you pass this data to an AI algorithm, a deep learning algorithm, and then it makes a prediction on whether it's a pedestrian, whether it's a cyclist, whether it's a car. Is that how this process works?
Yeah, I think of course it's a bit oversimplified, but
Mm-hmm.
that's the generic idea indeed. The radar goes in, and then some usable outcome comes out, that a list of objects around or a polygon where you can drive, these kind of things.
And so from the three technologies, so you mentioned camera, lidars, and radars, right? Those are the three kinds of technology you could use to detect things around your car, and so essentially to get autonomous cars. So yeah, I'm keen to understand a bit more about radars. So first question is, can we have fully automated vehicles using radars only, or do we need a combination of radars, cameras, and lidars? Because you mentioned there are three kinds of technologies: cameras, lidars, and radars. And then my other question is, what are the pros and cons of radars compared to those two other pieces of technology, so cameras and lidars?
Okay. Well, the first question is a bit tricky. You said autonomous vehicles. I would say self-driving cars, like really out there, no, it won't happen purely based on radar. Also, it shouldn't. Um, Redundancy is key for safety. Other sensors has to be there. Also, they're kind of complementary. This takes us to the second question, but let me first say that
Mm-hmm.
maybe you can set up a domain where it would work, like I don't know, in a dark environment, predefined boundaries. I can imagine that in, I don't know, underground mines in super darkness, you don't really have other options. For example, or there's a reason that ships mostly use radars. So in some environments, this is a must to do, like purely radar-based solutions. But whenever it's possible, you should do some kind of fusion. And then the reason to this is the difference between the sensors and besides the robustness and redundancy that is critical. So yeah, we used to say that to really drive yourself, or a car to drive itself, you need robust, affordable 3D understanding of what's going on around the car, right? So then you have the robustness, I mean, like, hey, if there is a little bit of rain or smoke or fog or snow, or not even that, just, it's a sunny day and it's something comes towards your sensors, cameras and lidars are really suffering. Like,
Okay.
when we go out in the winter and there is, it's cold and there's the exhaust from the engines, then the lidar can see that and it's like a ghost flying through the scene. And then, of course, it's dangerous. Imagine you're driving, I don't know, 80 kilometers per hour, and then your car thinks there is some huge solid objects in front of you. It will press the brake. Same with the sun for cameras. Camera is also not that great during the night and snow. Radar, purely because physics, so it's not magic or not AI, is using different wavelength, and because of the different wavelengths, much larger actually than the other two, it's basically ignores these kind of things. It goes through snow, it goes through fog or rain. It isn't bothered by visible light, by sun. So that's a great benefit. Then we mentioned affordable, right? Cameras are pretty cheap, although if you want to buy like industrial version, and it's getting a bit more expensive. So like $100 per car is what a big OEM would pay for a camera. A radar is like 30 to $60. So
Okay.
it's half of it. And then you go to lidars, and then it really goes out of hand. So that they are the big dream is that it will get under $500
Okay.
per car, but that's still far away. If you buy a single lidar now, like a startup buys one, then it's definitely thousands, like at least 2,000. And if you buy a really good one, then it's 20,000. It's a really really good sensor, so don't
Mm.
get me wrong. The output is amazing. It's just not. It's not going to happen in the streets of, I don't know, South India. You won't see LiDAR-based ADAS systems in the next
Mhm.
10, 20 years. Then there's the 3D part. LiDAR is 3D, radars are 3D, um, cameras are not. They are really good in, lateral resolution. And basically, the whole motivation we started this startup is that cameras had the AI hype, lidars had the AI hype, and as discussed before, radars were a bit ignored. And we thought that, okay, it's a good sensor, it's clearly affordable, clearly robust, clearly 3D. Why not smash some
Mm.
nice deep learning on it?
Yeah, so can you talk a bit about your company? Then you study computer science, you do some projects on drones, on autonomous vehicles, you do your PhD related to autonomous vehicles on road user detection using radars, and at some point you decide to create your own company and focus on radars, as you mentioned. So can you dive a bit into this? Why did you decide to create your own company, and what is Perciv AI? What is your company doing?
Sure. Um, yeah, so as described before, the whole PhD was, hey, how to detect these road users better, and then we dived into maybe radar is the right way. Um, so that's actually a funny thing that we are not radar people who, so we're not making better hardware, better sensors. We were self-driving people who found a better sensor to do this with, and then we learned into the job. And this is my whole PhD and actually my postdoc as well, that how to do this better and better. And I seen that there is like a huge academic gap, like a couple dozen people, dozen, so like one, two,
Mhm.
is doing this in Europe or was doing this, and I after a while I knew all of them, so it was a clear academic gap. And then I realized, actually, with my two co-founders, Shriman Narayana and Balazs, that it's not just an academic gap; it's an industrial gap. There was already a big interest from industry during my PhD that, hey, what is Andras up to? What are these papers can do? And it seems like that the industry is also recognizing that, yes, you can do a lot of things with the other two sensors, but no, it won't be enough, and you cannot afford in entry level cars to use those sensors. So we also did a pretty cool experiment with Shriman, one of the co-founders. His whole master degree, which I helped him writing as a supervisor, was hey, how to take camera and radar and simulate that it's a lidar. So it's a whole neural network taking these two inputs, and the output looks like lidar. And then everyone was bamboozled that oh, we can take $200 of sensors and mimic something that's 20,000. And then we were like, okay, that's clearly some business drive here as well. So in 2022 fall, we officially registered this company, the three of us, Shriman, Balázs, and myself. It's actually two Hungarians and an Indian making a Dutch company, so it's very multicultural. And the whole slogan was, okay, this is a Dutch machine perception startup. It's a spin-off from, or spin out rather, from one of the leading tech universities in Europe. What we do is machine perception with a heavy focus on radars. And the short slogan is AI for radars. We make these sensors smarter with next generation perception. And this is a software company, and this is a next generation automotive, in a sense that software defined vehicles are coming. Your cars is going to be a PC on wheels, not a car with a PC. And then many of these services will be software, and that's what we do. Like, okay, buy your favorite radar or your best friend making radar hardware. Some of them are really cheap, stupid sensors. Some of them are actually pretty expensive, but very good sensors. And we make it better for you. So whatever the radar input is, it will be more useful for you if you use our software on it. So that's the short story of Perciv AI.
Okay, cool. So yeah, can you tell me now the long story? I'm curious to understand how does this work under the hood. Maybe give an example of I'm a client. I bought a bunch of radars. Yeah, why would I contact you? What would you do with my radars to make them better? And keen to understand also how it works a bit under the hood. But essentially, what's the input? What's the output
Mhm.
of
Okay.
your software?
Yeah, let's start from the business perspective, and then we move towards the how it works. So let's say that you make cars. You are an Indian or Chinese or South American. It's usually these are the more open-minded markets, and you want to have your car being enabled with some kind of ADAS feature, and then you realize that, okay, to do this, I probably need radar. Okay, who makes radars? Then you go to the big ones like Continental or Bosch, and they are making radars, and they give you a really how to say this a price that is painful for you. So per car you pay, instead of the $60 I mentioned, you pay 160 because you are not that big, you are not Mercedes. And then the radar does something that gives you basically a predefined set of functions that, oh, I think there's something in front of us. Maybe press the brakes. And then so basically it's an expensive and kind of silly solution. And then comes Perciv AI, which says, hey, don't go to Conti, which is actually a good sensor with a good solution that it tells you that there's a car. Take any of the sensors you want, if as long as the point cloud output of it, so not this process that I mentioned before, which already tells you that there's a car, the point cloud version is okay. We make this function level output of it for you. Then you buy something like half as cheap add-on software, which is still much cheaper than the big boys, and you get something which is just as good or maybe even better because it's fine-tuned to your needs. So That's how the business perspective works. In practice, this would mean that you send us your radar prototype, or a couple of radars that you are interested in. We put it on our car, we record data, we annotate it, and then show in qualitative and quantitative manner that, okay, if you use our software with that hardware, it's going to look like this. If you use their software, then it's going to look like this, which is obviously pretty bad compared to ours. That's the whole message.
Mm-hmm.
So this kind of communications. Then under the hood, I can say that it's almost purely data driven. So that's a big change compared to existing or competition. Is that radars has been around for 60 years now, so it's nothing new. But the way they were used, it's these old kind of algorithms that we talked about at the beginning of this session, and those were all okay. You could do a lot of cool things with it. They are outdated now, so you can do more if you know what you're doing. So we have pretty good tool chains to go out with the car and put a radar in the front, some cameras on the top, and a lidar. And then using these two sensors, we automatically annotate that what's going around the vehicle. And then instead of manually annotating
Mm-hmm.
some stuff, we can train a radar-based neural network in a day or two uh, with your newest prototype. So I'm pretty proud of our in-house solutions, and yeah, a bit more into details. I would say it's scalable. So every you can have very advanced and latest neural networks going on there. Like transformers are huge for radars these days because it's actually it's a much sparser data than image or lidar. So all these extra processing times that these are bringing in transformers or graph neural networks. So that's I okay. Let me rephrase. The next generation of AI models are uh, historically always slow because they are very uh, inefficient in terms of computation, and the more data you have, the more they struggle. Actually, many of them starts with, okay, let me throw away, I don't know, 80% of the data or downsample my image because it's just too much. And radar is coming from the other way, right? It's already sparse,
Mm-hmm.
so you don't have to do this. But thus, all these new methods are kind of make sense with it. But of course, you cannot really put a transformer on these little chips that's already in the radar. So we very much prepare to downscale these algorithms and then have teacher-student networks, for example, that, okay, you have something that's really smart, training something that is really small. And then the small one has to mimic the
Okay.
capabilities of the big network.
Yeah, it's very cool, this automated annotation thing. So, from what I understand, you've got your main database with lots of data. Obviously, you need a lot of data to train, to build autonomous vehicles. But you've got also your automated annotation part, which allows you to fine tune algorithms for specific cases, so for specific companies or for specific types of radars. Is that why you need this automated data collection?
Yes, I think that's a good way to put it. That we are shooting to be hardware agnostic, so that means that we are not married to any of the radar makers or their models. We have like a foundational radar model, but indeed, as you mentioned, some fine tuning is always needed, and it's not just fine tuning; it's also if you're company A, then you're not interested in our results with company B, or maybe you're interested, but up to the point that, oh damn, they can do this with my competition, then let me also buy this software.
Mm-hmm.
But then you're interested, okay, but you put my radar on it. I don't care of company B, and yeah, so to really do that in a quantifiable manner, that it's important to measure your results. And that's why we go out and do this offline auto labeling, and it really maps every car, every cyclist, every pedestrian around, and they are tracked continuously. And then for the radar, of course, we simulate that this is the first time you ever seen this scene. Would you tell me that's a pedestrian or not? It's a very challenging task, but that's why we are here.
Okay, no, that's very clear. And then I'm keen to understand a bit the output side of things. What would be the output of your system, your software, and how would company use this output to basically build autonomous vehicles? I guess they cannot go fully autonomous with your system, or perhaps they can. What's the output essentially, and how useful is it at the moment?
Okay, yeah. So the name of the company is Perceive, after the verb perception, to perceive. So that's really our focus to to just understand what's going on, and the control we push a bit towards the car maker or the whoever makes a robot taxi. Uh, we selected this part of the job to
Okay.
do the perception, and thus the output is really a kind of representation of the environment. This could be bounding boxes. You're familiar with that in 2D, right?
Mm-hmm.
Um, we do the same in 3D. That okay, I believe there is a box with this class, with this shape, with this size, and this orientation. Over there, I would put track ID 8 on it, and I think it's a bike. And that's one kind of output. And maybe some confidence score on it as well, that okay, I'm pretty sure that it's there, but maybe it's 60%. And then whoever is integrating our software has to turn this into a function, and this function can be an emergency braking system, that okay, if something is coming from the left in front of us, we should press the brakes right now. It can be a comfort system, that okay, if Perciv AI says that I cannot drive more to the left, but there is some
Mm-hmm.
space on the right, then maybe do some smooth control. Um, so how it is integrated later is a bit up to them. But what we see now is a big push from regulations, that new cars have to match um, stricter and stricter regulations, and that's a very good thing. That next year or the year after, you cannot buy a car which cannot do this or that. And what is this or that is getting stricter and stricter.
Mm-hmm.
But think of stuff that okay, pedestrian coming from the left in low visibility, it's dark, your car still has to stop, and then the car maker has to match this. He literally not allowed to sell you a car if they cannot, and that's a great thing. That's how we increase road safety. But then someone has to actually implement the feature, and these kind of outputs that we give, that yeah, we believe there's a pedestrian coming from the left, helps the automakers, that okay, if Perciv AI says that, let us press the brakes, then we pass the regulations, then you can buy the car. That's the long-term vision.
Okay, so am I right in saying that you're augmenting a very simple radars? You're basically augmenting it by um, people can buy a very simple radar, but you augment it by using the data and really outputting lots of information from this simple point clouds data that you get. So you output info on whether there is a cyclist or not, whether there is a pedestrian or not, whether they can drive to the left, to the right. But then it's up to the company that owns the radar to process this information to include it into the car. But you're really augmenting the radar with AI to give lots of information to your clients so that they can then, I'm putting some quoting marks, easily build or more easily build autonomous vehicles. Is that the correct way to phrase this?
Yeah, I think that's a nice way to put it. So we take existing hardware and make it smarter, and we believe that we push it to its current state of the art boundaries. That okay, that's the most you can do with this hardware. and
Okay,
then
so
indeed someone integrates it.
okay. And what's your specific role inside the company? What are your current challenges today?
Okay, so there are the three co-founders. Uh, we kind of do, it's a small startup. We do everything,
Hmm.
all of us, but I would say I focus on the technical stuff. So of course the experience of PhD, messing up the same stuff 20 times, then maybe the 21st time you're a bit more. Oh, it could be again you swapped X and Y, these kind of things. But I'm also very involved in business development, so networking and going out to potential customers and really give presentations of what we can do. And then, of course, with the automotive is a conservative industry, so
Hmm.
they're a bit skeptical. And if you can show that, oh, by the way, you have been doing this for 7 years, then they are a bit more like, okay, fine, I will listen to this. But if you don't have this background, it's even harder, I would say. So that's my two focus: tech and networking. Then my two co-founders, they focus. Balázs focuses on business, I would say, like strategy. How will this actually be a profitable business? What are the milestones we have to match to that? And then Shriman is really, I call him the hammer. Uh, he's is very multifunctional. He jumps on a task whenever it comes in, and but he's really in charge of operations, like day-to-day task, getting the company rolling, make sure that every invoice is paid, but on the other hand, every deliverable is done. These kind of things, and that would be the roles. We have two more full-time employees now, and four interns, so it's a team of 9. We are growing this year as well. The challenges, I would say, probably the very slow and conservative nature of automotive. To really explain them that, okay, what you can do is attractive. It takes time, and maybe for a startup it takes too much time. And then
Hmm.
it's a fine balance that you have to educate your audience and then wait for it and still stay alive and do some other stuff, the drones that you mentioned, for example, to get some revenue and keep going and still develop a foundational uh, stack that can address the problems for multiple fields.
So you think you're maybe a bit early in the market, so you need to be a bit patient, and or you just need to be patient and take the time you need to convince your clients that you're the future and the way to go.
Yeah, it's rather the latter. It's so we are definitely not too early in a sense that um, every conference I go, radar is getting more and more popular. It's like it's like the from at the high school reunion when the used to be fat kid shows up and then it's now super fit and handsome. That's how it feels like radar, that nobody used it, and now every conference I go, people are like, oh yeah, we should do something about that. So the time is right. It's more about patience that we jumped at the right moment, and now we have to educate that, okay, we can actually deliver here.
So the 10 million question is 10 million euros question is, when do we get fully automated vehicles? What's your take on this? Elon Musk says it's next year, every year. So is it next
Exactly.
year?
So in my PhD, every chapter had a quote when you start reading the chapter, and one of my quotes were actually from my professor, Professor Gavrila, who was with Daimler for 20 years, and he said, "Self-driving cars are always 10 years away." And this is true regardless the current date. So this statement is, pushed a long time. Um, yeah, it's a tricky question because okay, how you define self-driving and what to what level. Do you expect them to actually be completely self-driving? I don't think that fully self-driving is going to happen in the next 20, 30 years, like literally everywhere, uh, completely autonomous. L4, which is, on a well-defined region, maybe a pre-mapped something, imagine a port, imagine the fenced-off factory, and then it's doing its job. Uh, that will happen. It's actually happening right now, I would say. But to be honest, that's not we are in this game. We are not here for self-driving. We are a big believer of ADAS functions that it's elevating safety, it's elevating comfort, but mostly safety. There's so many people are dying every year on the roads, like it's 1.3 million or something like that per year. So like completely unnecessary. Like there's no reason for that. Um, and I would say we should focus on that, increasing safety, uh, press the brake sooner when a kid is running in front of you, and that's the important thing, not you know having a smooth ride in San Francisco and keeping your Starbucks latte balanced during the ride. That's nice, but it's
Hmm.
not the focus.
Okay, no, yeah, very good point, and that's kind of an interesting thing. People think, yeah, I think people think a lot on fully autonomous or not autonomous at all, but you can also have a balance, or you can even include a few safety things into your non-autonomous car that will make it safer. So yeah, I think that's a very good point, and it's great that you're working on this space. Sounds like a super exciting space to watch. I want to move now to the last part of this conversation, the career side of things. Just two questions before we finish the episodes. The first one is, well, this show is called AI Stories. It's all about people and their stories. So I'm keen to get one story from you. It could be anything funny, it could be something interesting, a mistake you've made, whatever. But can you please share one story about you?
Well, actually, I prepared the two stories, if you don't mind,
Yeah,
but
go ahead.
we can always select one. So I one of my favorite stories is when I was still with the startup and we were doing computer vision. We also had traffic monitoring and parking spot counting. Like there was cameras on top of huge metal poles looking down and seeing that, okay, that parking spot is taken, that is free. And we realized that our accuracy was dropping during the day, and then in the night it was again okayish. And it took us a while to figure out that the algorithm is working okay. Is the pole that is getting uh, being the sun is hitting only one side of the pole, so it's getting a bit longer, and the whole pole was tilting because of this effect. We call it the sunflower effect. Basically, the whole um, the whole view was miscalibrated because something that you assumed to be static wasn't static. The camera was literally moving. So one of my job was to estimate this extremely slow but existing ego motion of the camera, like how much are we moving to the left and then back. So that was a very interesting topic, but more to the
Did you solve the
self.
problem in the end
Yeah,
then?
yeah, yeah. We did solve it, but just the fact to realize that your basically my message here is to question your biggest assumptions. There was a huge assumption here is that our sensor is static, and that wasn't true, even if it makes sense. But it took us a while to figure out. But yeah, we did solve it. So once you know the problem, it can be solved. Then my other favorite is was already here in Delft. That the first time we actually got the car moving, in self-driving manner, that it was driving itself. And I was the safety driver. Again, it was 10 years ago, it's a bit different, a bit Wild West, but it was a test track. So safe environment, but still, first time a, a one-ton vehicle is moving itself. Then the guy on my right, I won't put names in it, but he was coding the control. I was the guy in charge to grab the wheels, and then he pressed space. We started going, and then at some point he started shouting, "Stop! Stop! Grab the wheel! Stop! Stop!" And then the car was starting to move off track visibly, but luckily we all stopped in time, and that wasn't a super close call, but it was definitely time to stop. It turns out that um, before you do such kind of experiments, you should really align the units that you are using. That is it degree or radian, or is it meter per second or kilometer per hour? Because he swapped both of these, and of course, it was a huge misunderstanding. And it's just like the famous story of NASA landing on the Mars or whichever it was. Both are okay. You just have to agree on beforehand. So that's the other story I would like to share.
Okay, but at least you didn't get injured or anything.
No,
He stopped
no,
on
we are all
time.
good. Yes, that
You're
was my
still
job, right? To
yeah,
like,
you're still
I
alive.
didn't. Yeah, actually, that's how we always do recordings. That one guy is purely driving, and then the other is doing everything, exactly for these kind of reasons. It, it happens.
Okay, so let's finish the episode with one question. If you just had one advice for people to progress in their career, what would it be? Just one advice.
Yeah, I was also thinking of this beforehand. I think it's a very actual question because our field is changing so fast, right? Every day there is a new AI approach. There is a new AI chatbot coming out. Um, so what I would recommend is instead of learning how to be a super good coder in one language or focus on one set of pipeline, learn how to think, like how to really think like a programmer, think like a researcher. Because if you can do that, then you can jump from one language to the other. You can make the most out of the even the best AI tools that are helping you writing code. But if you don't understand the back end story of these algorithms, then you ask ChatGPT to write you a solution to this problem. It will. It probably will be. Sometimes it's actually pretty good. Sometimes it's extremely stupid, but you won't know because you don't know how to understand at least what's going on. So I would suggest to always learn, to always read new papers, and really focus on the mindset instead of the very specific tools because those will be outdated in a year or two.
Well, Andras, thanks a lot. It was great to have you and get to learn from you. Have a great day in Delft, and yeah, hope to catch up very soon.
Yet, many thanks for having me. Looking forward for our next conversation we have.
Thank you.
Bye, everyone.